All right, we are moving on to Chapter 8, Section 1. We are working with sequences and series, and I like to throw this in early in the year so you guys can get through some statistics before you take the SAT or ACT. So the best time to take that is mid-February. Our essential question today is, how do you represent a sequence of numbers or the sum of a sequence? The first set of questions are pretty easy. They're just saying write the first 5 terms of each sequence. So it says a sub n is equal to 2 times n plus 1. So if I'm looking for the first 5 terms, I'm going to turn that n into a 1, that n into a 2, that n into a 3, that n into a 4, and then that n into a 5. So typically when they're talking about the first 5 terms, they're talking about 1, 2, 3, 4, 5. Now, I have not answered the question. So 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6, plus 1 is 7. And then we have 9 and 11. And you'll see a little pattern here, 3, 5, 7, 9, 11. And those are going up by odd numbers. Hopefully on the next one, you'll see a pattern as well. So we want to take note of what's happening when I take 2 minus negative 1 to the first power. Well, negative 1 to the first power is negative 1. So 2 minus a negative 1 is just plus 1, which is 3. Notice the next one, we have it to an even power. Well, when I have that even power, remember that even power means that this is going to be a positive 1. So 2 minus 1 is just going to be 1. But look what happens when I go ahead and put in that 3, 1, 2, 3, we're going to have that odd power again. So it's going to go back to 3. So what do you suppose is going to happen when I put in a 4? Good. And a 5 is going to go back to 3. So I'm going to throw this in the calculator this time. It says in example 2, write the first 5 terms of a sub n equals, in the numerator, 2 plus negative 1 to the nth power, which we did 2 minus, but now we're doing 2 plus, all over n. So if you can see down here, I have it on your TI-84. You're going to go to second stat. In stat, you're going to scroll over using those gray buttons to go to OPS, and we're going to be at number 5. Now, if you notice this stat, it's really not called stat, it's called list. So when you hit second, list is on top, so that is the blue thing. And when I hit number 5 says sequences with a parenthesis. Now, if you don't have a newer calculator, it's not going to come up nicely for you. I'll have to teach you a different way, or you'll have to Google it. So the first thing they're going to say is we need the expression. So this is where you're going to have to put this in. So remember to pull up that vinculum. You're going to, actually, you know what? It's probably easier if you put in an open parenthesis and then do 2 plus, open parenthesis, negative 1 to the, and in this case, we're going to use an x power. And then you have to close the parenthesis and divide by x. Again, we're using an x, not an n, because that's what we have on our calculators. So that's the expression that we're putting in. Then we have to tell the calculator that we're going to use the variable of x. And because they're looking for the first 5 terms, remember we're going to start on 1 and end on 5. And because we're not going up by odds or evens by every 3, we're going to put the step in. So it says variable, sorry I'm not writing this all out, and then it says start. So remember we want the variable to be x, we want it to start on 1, we want it to end on 5. Sometimes they ask you to start on 0. And then it says step. Step means we're going up only by 1 because we want it to go 1, 2, 3, 4, 5. So sometimes they say odd or evens. Step 1, and then when you hit enter, you'll notice below it says the word paste. You actually have to take that and hit enter again, and it pastes to your calculator. When you hit enter from there, I'm going to hit math frac because I want to see it in fractions. It gives you the answer as 1, 3/2, 1/3, 3/4, and 1/5. Of course, you can do this by hand, but I just want you to be aware that this is full functioning on your calculator for an SAT or an ACT. All right, for this next part on example 3, this is where I have some students that really struggle. Hey, what's happening here? How do I write an expression for the apparent nth term? So the first thing I want you to do is I want you to look from 1 to 5. It goes up by 4. 5 to 9, 4, 9 to 13, 13 to 17. These go up by 4. So typically, that means we're going to have 4 times n. Well, if I take 4 times 1, because remember we always start on 1, if I take 4 times 1, I get 4. But remember, I want my first number to be a 1, so I'm going to subtract 3. Well, what happens if I plug in 2? 4 times 2 is 8. 8 minus 3 is 5. Hey, that works. What if I plug in 3? 4 times 3 is 12. Minus 3 is 9. So I think we're good here. And the next one isn't as user-friendly. The first thing that I notice is, oh my gosh, it is rotating from positive to negative to positive to negative. So I know somewhere I'm going to have what we had at the beginning, where I'm going to have a negative 1 to the nth power. But I want it to start positively. So if I start on 1, I don't want this to be a negative answer here because this 2 is a positive. So I'm going to put n minus 1. And this one's kind of a tricky one because we haven't talked about anything else. But if you notice, this goes up by 8, and then this goes up by a lot, 19. And again, it goes up by a lot. So the first thing I want to cover with you is you have to know the pattern of n squares and n cubes. Let's talk about our squares. From 1 to 4 to 9 to 16 to 25. Do you guys see that these go up by 3, 5, 7, 9? Notice these go up by odd numbers. Do you all see that? Well, on the n cubes, I'm going to do that over here. Remember, these start as 1, and then 2 cubed is 8, and this is why I have you guys memorize these. And then 3 cubed is 27, etc., etc. Notice that this goes up by 7. Did you guys notice I made a mistake here? This should be a 7. Funny. And then this goes up by 19. Well, notice this is what we're seeing in our pattern here. So I know that these are going to be my cubes, but we didn't start on 1. We started on 1 more. And we went to 9. Remember, my second cube is 8. 2 cubed is 8, so we were 1 more. So this green right here, this is what's making it rotate to positive to negative. This term right here, n cubed plus 1, that's where I'm getting the numbers 2, 9, 28, 65. So you will need to be aware of n squared and n cubed. All right, the last thing we're going to do in this video is we have this thing called recursively. For some reason, all of you guys forget what recursively is, and I see it a lot of places. So the first thing I'm going to tell you to do is star, circle, and highlight this one, and we're going to work with recursively. It says write the first 5 terms of the sequence defined recursively. Kind of a weird word, and then when I look at this, notice a sub 1 is 6. But then they're telling us k plus 1 and k. Well, we haven't seen a k yet. So what this is saying is we're going to take this number 6 and we're going to put it in right for this a sub k. So I have 6 plus 1, and that's going to give me my a sub 2, which is 7. So what this is saying is, hey, we are going to take this answer and put it in to here. But now I have a new answer. I have 7. So now I have to put the 7 in for my a sub k. So when I put my 7 in, I have 7 plus 1, and that third term is going to be 8. And then I have 8 plus 1, and that fourth term is going to be 9. And they ask us for the first 5 terms, so 9 plus 1 is going to give me 10. So the answer to these first 5 terms, defined recursively, is 6, 7, 8, 9, and 10.